So today we are going to do a little activity to show us a different perspective when it comes to factoring, and then we're going to use that perspective to help us answer further questions that we haven't faced yet. So the first thing we want to do is introduce what the heck this activity is about. So I want you to think of a polynomial like x squared plus 3x plus 5, for example. All right, we have been practicing using the x method to factor that. So instead, I would like you to change the way you think about polynomials today. I want you to think of area. So for example, if I write x squared, okay, we can think of that from a geometry aspect if we just think of a square whose dimensions are x, because then the area of that square would be x squared. And usually you see an x in a polynomial. So I want you to think of, when you see an x, I want you to think of a rectangle whose dimensions are x and 1. And then if you usually have a constant like, plus 5 or plus 3 or something like that at the end, I want you to think of that as a combination of squares, all of who have an area of 1. So for example, if I said x squared plus x plus 5, I want you to think of that 5 as 5 separate squares. Each of them have an area of 1, because that would get you 5 when you add them together. All right, so we're just going to go ahead and tie that together and kind of label it, because this is what you're going to be working with. So if we think of x squared, I want you to think of a square whose dimensions are x by x, of course. So if you want to get the area of this large square, you're simply going to do x times x, which is x squared. Then I want you to think of a rectangle whose dimensions are x and 1. So if you want to get the area, again, length times width, x times 1 is x. So if you had like 4x, for example, I want you to think 4 rectangles. Each of them have an area of x, so that would get you an area of 4x. And then you're going to work with the small square tiles. So I want you to pretend that they have a length of 1 and a width of 1. So 1 times 1, the area is 1. So pretty much every polynomial I ask you to factor can be written as a certain number of x squareds, a certain number of x's, and a constant, all of which can break down into these 3 shapes right here. So I want you to think of it from a geometry aspect. These 3 figures right here are so popular, we call them algebra tiles, and we actually use them to help us factor trinomials. So it kind of gives you a visual representation of what exactly is taking place when you factor a trinomial. All right, so what we're going to do is we're going to use a link for online algebra tiles. So we're going to gather the tiles x squared, 4x, and 3. So that would be 1 of these, 4 of these, and 3 of these, because that would get you that combination. So I'll go ahead and I'm going to do this. All right, and this is just a free website that offers algebra tiles. I'm just going to really quick show you how to use it. So you can see you have your 3 tiles here. You have your big square, a rectangle, and a little square. And sometimes you might want your rectangles to be laying like horizontal. Sometimes you want to make them vertical, so you can pick either one. If you drag, let's say, a vertical, and you're like, oh crap, I wanted that to be horizontal, you can just rotate it, and it does it for you. And if you decide that you don't like what you have, you can delete. If you have a bunch of shapes and you're all kinds of in a mess and you're like, you know what, I just want to start over, just hit tidy and it clears your screen. So it's really easy to use. So we need to grab 1 x squared, 4 tiles, each of an area of x. So I'll just grab all these vertical ones. We'll see where that gets us. And then I need 1, 2, 3 of these tiles. So check again. You have 1 area, that's x squared, an area of x 4 times, that's right here, and I have 3 areas of 1 would make you have 3. So this area is represented with this picture below. All right, so what we're going to do is we need to arrange our tiles so that they make a rectangle. So we need to somehow get all these guys to work together to make a rectangle, and here's what you can't do. Right? You have to match up sides of equal length. So absolutely, you can match these sides up because this is x and this is x. So these are the exact same length. What we can't do is we can't do this. And here's why. So some kids might say, oh, it looks like you need 4.5 blocks to cover this green guy. The problem is we don't know how long this is. We called it X. So how do I know if X is 6? Is it X7? X8? We don't know. So, this is a side of 1. You can't stick it on a side that is X units long. But what you can do is you can put it here. Remember, this is X and this is 1. And this is a 1 by 1, so you're allowed to stick these sides together because they're both 1. So you just want to be careful about that. I'll go ahead and delete that extra little block. All right, so let's see. It just takes some playing around. So maybe I'll put 2 of these here. If I put these other 2 here, well, I have a problem because if I put my little blocks on this picture, that's not a rectangle. That has definitely more than 4 sides. 1, 2, 3, 4, 5, 6. That has 6 sides. That's not a rectangle. So you get a little bit crafty and think, oh, what if I spin one of these around, for example? What if I make one of them like this? I can certainly rotate it. That doesn't change the area. So maybe I'll try that. And I get 1, and 2, and 3. But that is better. It's not quite a rectangle. I'm missing one right here. So then, okay, what if I take this and I rotate it, put it here, and then this little guy has a hole, and boom, there we go. That is a rectangle. So what I'm going to do is take that and draw a picture below. So I have one green block on the top and 3 on the side. I put my little 3 squares right here. And then what I like to do is remember, this is a rectangle. So if we know how to write the dimensions, we can represent the area. So this would be X, and this is 1. So this side is X plus 1 units long. So that's why I wrote X plus 1. We have X, 1, 2, 3. So we have this side as X plus 3 units long. So then we're going to get the area of the rectangle. Remember, guys, when you're getting area, you can just add the area of each piece. Just add them all together. So you literally have x squared plus 4x plus 3. So just put a plus sign, and what you started with is your area. But that's not the only way we can get area. We can also use the area formula, length times width. Well, we established that the length is x plus 3 and the width is x plus 1, and then we can FOIL that out. And if you FOIL this out, you're going to get x squared plus 4x plus 3, so they go hand in hand. Okay, we're just trying to get you to see that connection there. Whether you add each composite area together, or if you just simply get the dimensions and multiply them, you get the same outcome. So they want you to write 2 algebraic representations of the area. So they want you to point this out that, hey, I can either write length times width, or I can actually FOIL it out, and that's what I'm going to get. Or I can just add all the pieces together, and I get the answer that way. So what you're going to do is you're going to practice that. So we have a whole bunch of practice problems. You're going to try to use those tiles to factor your polynomials just like I did. So we factored it into x plus 3, x plus 1. So you're going to do the exact same thing down here. All right, so you can give that a whirl, see how that goes. What I'm going to do now is I'm going to go ahead to the next portion of this and show you how to do it so that you can just go through this whole practice sheet uninterrupted. Okay, so this is where we're going to kind of develop a little trick to help us out of a jam. So we're going to take the following tiles, an x squared and 2x. So I'm just going to hit tidy, start with a fresh screen. I need 1 big square and 2 rectangles. That would be x squared plus 2x. We're going to arrange these tiles to make a square. Now don't get confused, because you may be thinking, well, I'll put one of them here and one of them here. Right? Kind of almost makes a square, but I'm missing a piece. That is exactly what I want to happen to you. All right? It says arrange your tiles to make a square. Fill in any missing spots with the tiles of area 1. So you should have just enough spots that you can fill in with these little yellow squares. And this is truly a square because the dimensions are x, 1, x, and 1. So if the length and the width are the same, that is the definition of a square. So what they want you to do is arrange these into a perfect square, fill in the missing piece with the little yellow blocks, and then we're going to write the area of our square. So again, remember, we can just add the pieces. We have x squared plus 2x plus 1. So that's one way you can write the area of the square. But you can also write the square as, or excuse me, you can also write the area of the square as side squared, right? So take the side times itself, that also gets you the area. So this side is x plus 1, or you can use this side, x plus 1, it doesn't matter. All you have to do is put x plus 1 in parentheses and square it, and guess what? If you were to expand this and FOIL it, you're going to get x squared plus 2x plus 1. So in this next page, it says, hey, gather these tiles that are on the left. All right, so grab x squared and 4 x's. Arrange them into a square. So I'll just put one on each side here. All right, so I have an x by 2 and x plus 2. And I'm going to fill in however many tiles I need to fill in. So 1, 2, 3, whoops, 3, and 4. So then you're going to record how many little blocks did you need to fill it in. And it doesn't matter how you arrange this, as long as you arrange it into a square, we are all going to get the same amount of yellow blocks needed. So you don't have to worry about like, well, what if I did this, turned it over here like this, and I moved this over here. You still need 4 blocks to fill in this picture. So it's going to work out as long as you make a square. All right, and then you're going to write down the area of your square. So I know I have x squared, 4 x's, and 4. So that's the area. So you're going to complete that chart. Once you complete that chart, there's going to be some follow-up questions that ask you about, hey, do you recognize any patterns? And if you remember, the number in front of x squared is a, this is your b value, and this is your c. They're going to ask you some questions about b and c to see what you've observed from your activities. So we'll go ahead and give that a shot, and then the next class period we'll go over the tiles activity sheet and see how you guys did.